In this video we are going to see how we find eigenvalues and eigenvectors of given square matrix A. Here we have an equation AV equal to lambda V, where lambda is called eigenvalues and V is eigenvectors corresponding to eigenvalues lambda, and V is a non-zero vector. So since V is a non-zero vector, by taking the determinant both sides we get determinant A minus lambda I equal to 0, and this will be a characteristic equation in the variable lambda. If we have n cross n square matrix A, then we will get n values of lambda and the corresponding eigenvectors. So we are taking a small example. A equal to 4213 is a 2 cross 2 square matrix. Then quickly let's see that how we are going to find eigenvalues for this square matrix A. So we take determinant A minus lambda I equal to 0, that is we subtract the variable lambda in the principal diagonal of this square matrix A. So determinant 4 minus lambda 2, 1, 3 minus lambda equal to 0. That is we subtract lambda in the diagonal entries of this matrix A and we take determinant of it. We solve it, we get 4 minus lambda, 3 minus lambda, minus 2 equal to 0. We further simplify it, we will get lambda square minus 7 lambda plus 12 and minus 2, that is plus 10 equal to 0. Then we factorize it, we get two factors, lambda minus 2, lambda minus 5 equal to 0, and we get two values 2 and 5. So these are the eigenvalues. What are these? These are the eigenvalues for the matrix A, square matrix A. Now we are going to find the eigenvectors. So first we take lambda equal to 2 and let's find the corresponding eigenvector V. 1, suppose v1 equal to x1 x2. So we have equation again, av1 equal to lambda v1 a minus lambda I, this time matrix. So when we solve for eigenvector, then you take matrix, not determinant. Determinant you take to find the values of lambda only. So here v1 equal to 0. A minus lambda, what was the A was 4 2 1 3. So we subtract lambda here, lambda equal to 2 in the diagonal entry. So 4 minus 2, 2, 1 and 3 minus 2. What we did, we subtracted eigenvalue 2 in the diagonal entries of our matrix A. So 4 minus 2, 2, 1 and 3 minus 2. V1 we take x1, x2 equal to 0, 0. Now 4 minus 2 is 2, 2, 1, 1 and x1, x2 equal to 0, 0. Now we reduce this matrix so that we can get the values of x1 and x2. We reduce this matrix R1 divided by 2. So 1, 1, 1, 1, x1, x2 equal to 0, 0. R2 minus R1. You get 1, 1, 0, 0, x1, x2 equal to 0, 0. Now we multiply this row with this column x1, x2 and we get equation x1 plus x2 equal to 0. Or we can write x1 equal to minus x2. Now our x1, x2 becomes we put minus x2 in place of x1, x2. We can take x2 common, minus 1, 1. So this vector is the spanning vector for v1. So we call it eigenvector v1 is minus 1, 1. So we take the spanning vector for this. Now this is eigenvector. This is, what is this? Eigenvector for eigenvalue lambda equal to 2. Now our second task is finding eigenvector v2 for the another eigenvalue lambda equal to 5. So again what we take, lambda a minus lambda I v2 equal to 0. Take v2 equal to x1, x2. Now a, what was a? I am writing again 4, 2, 1, 3. So what we do, we subtract lambda equal to 5 in the principal diagonal of the matrix A. So 4 minus 5, 1, 2, 3 minus 5, x1, x2 equal to 0. What we did, we subtracted eigenvalue 5 in the diagonal entries of matrix A, given matrix A. Now next task is reducing this matrix. Minus 1, 2, 1, minus 2, x1, x2 equal to 0, 0. So we R2 plus R1, so we get then R2 0, minus 1, 2, 0, 0, x1, x2 equal to 0, 0. Now we multiply this row with this column, we get minus x1 plus 2x2 equal to 0, x1, so you bring x2 in the form of x1 or x1 in the form of x2. Now what is v2? v2 equal to x1, x2. We can write 2x2 in place of x1. So 2x2, x2. We can take x2 common, 2, 1. So this vector 2, 1 is a spanning vector for our eigenvector. So v2 will become 2, 1. What is this? This is eigenvector for which? For eigenvalue lambda equal to 5. So we found two eigenvalues for given eigenvectors. We find two eigenvalues 2, 5 for the given square matrix A and corresponding eigenvectors v1 and v2.